when we consider how we build houses in New Zealand today, well, unfortunately, the materials we use the most are the ones we waste the most. So the structural materials such as concrete for the foundation, plasterboard for bracing, and timber for load bearing are what you would find most commonly in landfills today. And that's because we demolish houses at the end of their life, and we do that because we do not design them for anything else. So what we're essentially saying with our current design approach is that the image at the top equals the image at the bottom. But that doesn't have to be the case. At the University of Waikato, we research how recyclable waste or virgin plastics reinforced with natural or glass fibers can be used for the structural frame of a house. Now, typically, the frame of a house has to bear the weight of all the building materials, so the vertical loads, as well as the wind pressure, so the horizontal loads. Now, when we calculate these loads based on the building standards and knowing the material properties, we can input that information into a software that we use as a shaping tool. Now, that software will consider the top and bottom parts of the wall as blank pages, and it will apply an algorithm to compute or to draw the optimal distribution and quantity of material needed for that specific building case. When it comes to actually building the thing, we rely on a system of bolted plates that allow us to assemble and disassemble the top and bottom parts without damaging them. And when it comes to getting the manufacturing flexibility we need to achieve the optimized designs we came up with, we research how we can 3D print these materials into the shapes we want. So what do we get at the end? Well, at the end, we have material efficient wall elements, top and bottom, that we can repeat throughout the building's footprint to create its structural frame. Whenever we have a window or a door, we can use exactly the same methodology, but this time to drive the loads away from these openings. And thanks to the bolted connections, we can disassemble a part of the wall for repair, we can swap elements for stronger ones if we need to add a floor to the building, or at the end of life, we can deconstruct it piece by piece so that we can recycle and reuse all the elements without sending anything to landfill. So yeah, I know that we're all about breaking walls here, but maybe in this instance we want to deconstruct it. Thank you.